Hello, Algebra 2 class. We are looking at using reference angles to evaluate trig functions. Another way for us to establish the value of particular trig functions when we are working with them on a coordinate plane. So the first practice problem that we're going to be doing in this guided practice is working with the angle 135 degrees. So I've drawn this on a coordinate plane, so our angle opens up like this. And everything you see in black on this diagram was given to us. I did add in some red here. That will be crucial to working out the cosine of 135 degrees using a reference angle. The reference angle is always the angle that is formed between the angle that you're given and the x-axis. So we have to ask, for this 135 degree angle, how far would we need to continue to go to reach the x-axis? Well, since 135 plus 45 is 180 degrees, this reference angle will be 45 degrees. I can find that easily by taking 180 minus 135 to find out the measurement of that angle. The next thing we're going to do is we're going to figure out for this angle here, what would be the x and the y sine values. So here, I would have to go to the left. That would be a negative sign, and then I would go up, so that would be a positive sign. So my cosine value will be a negative because a negative over a positive is a negative. And I'm showing that right here. I'm finding the value of my cosine at 135 degrees using this reference angle and marking up the triangle that I can form from that reference angle. To the left, negative, up, positive, and of course, my hypotenuse is always going to be a positive value. So that's where I got this. Cosine of 135 degrees is negative, coming from this negative, over positive, coming from the hypotenuse here, my r value, my radius value. And a negative divided by a positive is a negative. So we're going to make sure we include this work on our paper. This will be important to deciding what sign we'll need to work with. The sine of 135 degrees, well, based on our reference angle, would be our y, which is positive, over our r, which is positive. Positive over positive is a positive. Okay, so now what we're going to do is we're going to take our cosine of 135 degrees and we're going to rewrite it with its reference angle. The reference angle will be negative to start with because we've already established the cosine of 135 degrees is a negative number. And then we're going to find the value of that reference angle. So it'll be the opposite of whatever this reference angle is. And when you plug in to your calculator negative cosine of 45 degrees, you'll get negative 0.71. You'll also get the same value if you plug in cosine of 135 degrees. You're going to want to try that to start to really see that connection between the angle that we're given and the fact that the reference angle will give us exactly the same value. So both of these, cosine of 135 degrees and negative cosine of 45 degrees is negative 0.71. Now we do the same thing for sine of 135 degrees. We figure out what we will have, positive or negative, attached to our reference angle. Sine of 135 degrees would be y, positive, over r, positive. Positive divided by positive is a positive. Sine of 135 degrees then will be equal to sine of 45 degrees. This time we won't have a negative here because the sine of 135 degrees will be positive. Y over r, positive over positive. So that reference angle, sine of 45 degrees, will give us exactly the same value as sine of 135 degrees. That'll give us 0.71. Okay, let's try another one. Guided practice B, we're going to take a look at the reference, we're going to look at the angle 230 degrees. We're going to find the reference angle for that. And then using that reference angle, we're going to find the value of that function. And we're going to notice it's exactly the same thing as our calculator tells us when we plug in the actual angle for that function itself. Okay, so let's first of all find 230 degrees, somewhere between 180 and 270 degrees, so we will stop in the third quadrant. To figure out what the angle is that's formed between the angle that we're given and the x-axis, this time what we're going to have to do is we're going to have to take 230 degrees, the total angle, minus 180 to give us this 50-degree measurement. So we are subtracting here, 230 minus 180 is 50 degrees. So our reference angle is 50 degrees. Now we're going to mark on our diagram here what our x and our y values are. To get over here to our terminal side of our angle, we'd have to go left, negative, and down, negative. Of course, the radius here, our hypotenuse, is always going to be a positive value. If we're asked to find the tangent at 230 degrees, then we're going to notice that we will have to do y over x, negative over negative, giving us a positive. So our tangent of 230 degrees will be positive. The sine of 230 degrees, well, to find sine, it would be y, which is negative over our radius, r. So that would be negative over positive. Negative divided by positive is negative. So we're going to have to attach a negative sign to our reference angle of 50 degrees. All right, let's work these out. Tangent of 230 degrees will be the same thing as the reference angle tangent of 50 degrees. Again, we established that was positive right here. And when we plug that into our calculator, no matter which way we plug it in, tangent of 230 degrees or tangent of 50 degrees, we're going to get 1.19. Of course, we're rounding these off to the nearest hundredth. Sine of 230 degrees, well, that's going to be the same thing as the opposite of the sine of 50 degrees. We are going to have to put a negative sign on that because we established that sine is negative down here in quadrant 3. Negative, that's our y, negative over our r. Positive. Negative divided by positive is negative. So that's why we put a negative sign on sine of 50 degrees, our reference angle, because in the third quadrant, sine is negative. When you plug into your calculator sine of 230 degrees, you'll get the same exact value as negative sine of 50 degrees. Rounded off to the nearest hundredth, you'll get negative 0.77. All right, let's try one that happens to fall in quadrant 4 to finish up with our guided practice problems. So first, we're going to draw the picture for the 300-degree angle all the way around. Stop here in the fourth quadrant. And to figure out what our reference angle is, we need to find out how far apart this angle is from the x-axis. To do that, we will subtract 360 minus 300. It makes sense to figure out our 60-degree angle. 300 plus 60 is 360. 360 minus 300 is 60. So our reference angle is 60 degrees. We're asked to find both the cosine and the tangent of that 300-degree angle, so we need to establish for our reference angle we need to be positive or negative. So let's go ahead and mark it up here on our diagram. To get to this point here on this terminal side, we would have to go right and down. So our cosine will be positive over positive. Cosine positive over positive is our x over r. X over r positive is positive. For our tangent, what we're going to do is y over x. That's going to be negative over positive. Negative over positive is a negative. Okay, let's go ahead and write this out now. Cosine of 300 degrees will be the same thing as the reference angle, cosine of 60 degrees. We already established it will be positive. So either way you plug this into your calculator, cosine of 300 degrees or cosine of 60 degrees, you're going to get 0.5, which rounded off to the nearest hundredth, 0.50. Tangent of 300 degrees is going to be exactly the same thing as negative tangent of our reference angle, 60 degrees. Remember, we established down here that we're going to have to attach a negative to our reference angle to end up with the correct sign value on our answer. If you plug in tangent of 300 degrees to your calculator or negative tangent of 60 degrees, either way, you're going to get rounded off to the nearest hundred, negative 1.73. So we're finding out that we can use reference angles, and when we're using those reference angles, we simply have to establish the sign that we would need to attach to it to find the value of an angle that falls anywhere on 360 degrees around the coordinate plane. And it actually works if you continue to wrap around that coordinate plane and go to higher degree values than 360. For right now, we'll go ahead and stay within the 360 degrees. Using the methods we just learned, I would like your paperwork, please, to look like what you see on these guided practice problems. All right, that's all for now, and we will see you next time.